Good afternoon, ladies and gentlemen. I hope you enjoyed lunch. It's my great pleasure to be able to introduce the second session of the October 2024 DSF Oktoberfest. Just a couple of reminders before we get into the meat of the talks. If you've been on the phone at lunchtime, please just make sure it's set back to silent to avoid disturbing our speakers. To remind you, there's a competition on the inside of your booklet and your swag bag with the chance to win some prizes. We'll be announcing at 5 o'clock. And you also have the chance, if people haven't drunk the place dry, to get a free beer with the back of your booklet as well. So, my great pleasure to be able to introduce our first speaker of the afternoon session, Ed Norton from the Trade Desk. He's been working in data science for about 10 years and previously was at Tesco and Meta and Facebook. So over to Ed.
Okay, thank you everyone for coming. So, let's kind of get into my talk. Obviously, I hope everyone enjoyed lunch. I don't know about you guys, I think German sausages are the worst. Got about 50 laugh, not a terrible audience. We can work with this, we'll keep going. So, firstly, I want to thank the organisers, my colleagues at the Trade Desk, and obviously everyone for turning up to this, and the people who are still turning up, it seems. So yeah, as noted, I've been doing this for about the last 10 years, currently a senior data scientist at the Trade Desk, and predominantly working in forecasting, but we'll get through that in a bit. Now, the eagle-eyed among you might have noticed the photo. It's amazing what a pandemic and a child does to you. In fact, one of the data scientists I work with, first thing he said is, what anti-aging AI software are you using? But yeah, so yeah. And if at any point I don't make sense, it's definitely me, it's not you. I'm a little bit tired because I have a little biological 6-month-old alarm clock who woke me up at 5 a.m. today. So yeah, hopefully we'll be able to get through this together. So obviously people hopefully came along for the massively snappy title. So when I was trying to come up with this, I spent about a week just trying to work out what I could call it. And then I asked my manager and he said, have you tried ChatGPT yet? And I said, well, I will. Then I chatted to our principal recruiter. He said, have you tried ChatGPT yet? I went, okay, fine, I'll try it. And rather pissed off because it actually came up with quite a good title. So thank you, ChatGPT. First bit of data science. Okay, so we're going to move through the agenda. So broadly speaking, this talk is going to kind of do a bit of a funnel. We're going to start right out with the Trade Desk itself, then kind of data science at the Trade Desk. Then we're going to work into forecasting and then work into a metric within forecasting. So we're kind of going in this way. And right at the very end, we will have a little look through actually some of the UI, so kind of our product, and kind of show you how exactly the metrics we have get put in front of users and actually change decisions. So yeah, hopefully it should be a full flow. Okay, so let's start off. Data science at the Trade Desk. Starting with, who are the Trade Desk? So, quick show of hands. Who knows the Trade Desk? Yeah, okay, I know you guys know the Trade Desk. You work there. Okay, we got something like maybe third, top ends maybe. So, fortunately, these slides won't be useless. If you all knew who we were, this wouldn't work out very well. So what don't we do? To my investment bankers over there, we are not in banking. We are not a hedge fund. We don't do trading. So yeah, not a hedge fund. If you go away with one thing, we don't do that. Which probably leaves the question, what do we do? So we are what we call a demand-side platform. We're an ad tech company. So fundamentally what this means is we integrate with a bunch of companies. In fact, we work with probably more than a handful of the people you will see presenting today. I don't think we disclose all of them, but some of them are disclosed openly on the internet, so maybe they'll get mentioned at some point in the slides. But what this basically means is we allow these companies to integrate with our platform, and then we enable them to be able to place ads all over the open internet. And when we say the open internet, what we basically mean is everything that isn't what we call the walled gardens, which is basically Facebook, Google, Amazon, where they have their own platforms. But we do enable reach across places like Disney and the New York Times. And yeah, we'll talk a little bit around some of the bidding system a bit more in a bit. But yeah, that's basically what we do. Cool. This is a much more complicated view of what we do, or rather the eco-space in which we work within. So broadly speaking, we sit on the kind of more to the left-hand side, and I will point out where we are in a bit because it's quite hard to see. But effectively, ads flow from, I kind of see them as flowing from the left to the right. So you've got the demand side, which is marketeer, so these are people we want to place ads, and then it goes through to the publisher. These are places who have ad space that they want to sell. And basically, we sit somewhere in that ecosystem more to the left, which allows people to access all those ads. OK, we are there, by the way. If you really squint, you should be able to see us there. And we are in the DSP section, demand-side platform. Now, a little bit about the company itself. So yeah, we are a global company. So we have kind of 3 regions. We've got NAMA, EMEA, APAC. Our headquarters is in Ventura. And I guess the bulk of our workforce are in the US. But we have about 3,500 people, I think, roughly in the company. And about 10% of those are in our London office, which is in Farringdon, just around the corner. We also, I think we do sandbox sessions with Data Science Festival sometimes. So if you come along, you can see the office. It's very lovely. We've got a lovely pool table, table tennis, all the things you could ever want. We do some work sometimes as well. So yeah, big company, medium-sized company, I guess, compared to some of the huge companies, but big enough to get stuff done, small enough that we're still building stuff. So probably what people want to know, given it's Data Science Festival, is actually what about the data science team and how do we kind of structure ourselves? So data science team, we have about 95 people we call our nearest neighbors, and they are predominantly data scientists, but we also have some research engineers, research scientists, and some managers, some directors. But basically, these are the people working on data science products day to day. We also have engineers, which is not in this number, and there's hundreds of those. And they kind of help get our stuff into production. Sometimes we do it, sometimes they do it. But typically, we work in our product teams to deliver. In terms of where we are based, so yeah, DS is probably the bulk again, is in the US. Big offices in Bellevue and in New York, and a pretty big one, got a few down in the Bay Area as well. We've got about 15 data scientists in London, so fairly good chunk of us. Then about another 10 maybe over in Shanghai, and then just a couple of people dotted in like Toronto, Hamburg, Melbourne. And then we have maybe another 10 who are remote, not only in the UK, US, all around. And this picture here we have is taken from something we do every year, which as a company, which is Palooza. So we basically send the entire company somewhere. I think it's coming up in Denver in January, and last year it was in Seattle, and the year before that was in Singapore, which was very nice. But yeah, it's really good fun, and you get to meet up with the other few thousand people at the company. Now we're going to zoom in about the teams at the trade desks who do data science, and then we're kind of going to zoom in on a particular team, the one I work in, because it's the one I know best. So we split ourselves into 4 kind of broad areas. We have buying, and so basically the thing you should think about buying is these are the guys that work mostly before and a little bit during the campaign, and the next slide will make this a bit clearer. But we do stuff like forecasting, and it's basically trying to make sure that our clients are able to make smart decisions on the inventory that they're trying to target. And so, yeah, I guess our goal is to make sure that they're targeting the best that they possibly can to get value. Then we have performance algorithms. So if you want to know a lot more about this team, the talk last year by Gianluca, so Oktoberfest 2023, was all about performance algorithms. And these are basically the real-time bidding team. This is the people who work on high-performance algorithms that need to take us from A to B. A to B being this team has about 30 to 40 milliseconds to place a bid. And we'll talk a little bit about that. We'll touch on that a little bit later. And we see something like 1 trillion potential impressions a day. So we have data sets that are, I think we definitely hit the big data mark for sure. And a little fun fact about this team is we see, I think it's about 2 million people every second in the real-time bidding system. And that's about the population of Manchester. So if you can kind of imagine Manchester squeezing into a room, running in there, and then a second later getting replaced by another Manchester, the scale of these things is truly shocking. And then we have the measurement identity algorithms team. So broadly speaking, these people, they work on a few different things, but like the measurement side of things is all around how can we do attribution modeling. And it's basically how do I know that my campaign delivered. They also do identity modeling, which is like how do we know we're targeting the right kind of households and stuff like that. It's a bit murky. I don't want to go too deep into that. And the final team is innovation. This is basically our AI lab. So they work across the entirety of the business, trying to work out what areas they can use advanced AI and your deep learning models in to deliver value, typically on a slightly longer time horizon than maybe the slightly more tight schedules we have in our teams. The simplified view is a little bit like this. So yeah, buying working before the campaign and a little bit during, performance working during, and measurement and identity working after and a little bit during. Now, this isn't strictly true because our work leads their work leads our work, and it's a bit of a circle. But this is kind of an easy view of it. And then you've got innovation just spanning the entire company. Cool. We're going to be focused on buying today because, yeah, it's the one I do, so it's the one I know best. So the problem I work on in buying is forecasting. So let's talk about what forecasting is at the trade desk. And conversely, we're going to start with what it isn't. So most people, when you think forecasting, right, you have a lovely time series and you're sticking your ARIMA model or LSTM or other models that I probably don't know that are good at what they do. However, that kind of relies on being able to generate a time series. And as you'll see as the slides progress, actually getting to even that kind of time series is really difficult. So even trying to get to the past is hard, let alone kind of projecting that out to the future. And so that's really where the complexity of our problem comes from. It's the insane amount of permutations of the space of inventory, and this will become a lot clearer as I move forward. So yeah, what it is. So fundamentally, right, we have an advertiser, I don't know, let's give an example, WhatsApp, and give that one because that one's declared publicly. They come to us and they say, we are looking to target London tube stations for digital out of home. So you see those screens in the tube stations. They want to place a bunch of ads there about WhatsApp. And then they might come to forecasting and we say, okay, you can say what you're looking to target and we will feed back to you and say, you can spend £1 million or $1 million, it's normally in dollars, right, over some period of time. And basically, the idea is that this is fully generic, so you can target whatever you want. So whether it's, targeting people in Pittsburgh who love cats, on CNN who are on iPhones, or you could be a bit less specific. I mean, you can also specify things like, I don't want to hit this customer more than 5 times, for example. We don't want to saturate the customer where they, see your ad 300 times in a day, and it probably starts to lose its impact. Cool. So the way we see forecasting is basically as a simulation of the real-time bidding process. And in order to do that, we're going to touch very lightly on the real-time bidding process and then show why forecasting is the hardest problem. So roughly speaking, this is how the real-time bidding process works. So user goes and visits a website. Technically, there are stuff in the real world, like digital out of home, but generally speaking, someone goes to a website, then the person who owns the website says, I've got some ad space. I want someone to see an ad, please. They send something out to us. Then an auction takes place, and then someone wins, and we show them the ad. And that all happens in 100 milliseconds. So the kind of insane latency requirements here are absolutely mind-boggling. And we get only about 30 to 40 of those milliseconds. Now, with forecasting, we have to do effectively that process a lot of times. In fact, trillions of times, because there are trillions of potential impressions that you could be bidding on. And as such, forecasting has to try and create a solution that does that trillions of times. Now, obviously, we do a little bit of sampling and some aggregating. We don't literally run a trillion auctions, but conceptually, that's what we're trying to mimic. Okay, let's talk about forecasting itself. So basically, We have some inputs. So we have your targeting settings. So the client maybe goes into the UI and they specify, I want to target cat lovers or something like that. I want to run this campaign for a month, and they will have some kind of pricing strategy. So there is an amount that they are prepared to pay to win certain auctions, and maybe prepared to pay a certain different amount in other auctions. And we have some products around trying to make sure that they get the best price. And if you want to learn more about that, that's last year's presentation. And then we have a couple of seconds, so we have a little longer, but still relatively not that long, in order to deliver a bunch of metrics that can be taken by the client and then do something about it. So basically, they want to know how much they can spend. They want to know how many impressions they get, so how many ads are actually going to get shown, and stuff like your reach. So how many individual users am I going to be able to have an impression be shown to? And then there's a couple other metrics that I'm not going to go into now because specifically around relevance, we have a whole section for that. So we'll tackle that in a bit more detail. Cool. Let's move on to modeling. So forecasting modeling. So this isn't going to go super deep because I don't have loads of time for this presentation. But if you do want to know more about this, feel free to come find me at the stall downstairs afterwards. You can ask me anything, or I guess maybe find me with a beer in my hand at the end. Probably I'll be a lot more loose-lipped. So the way I kind of visualize forecasting is as a funnel. Basically, we start off very broad, and then as we model, we're kind of narrowing the space slightly. So we start off with our potential available impressions. So like, you want to target this particular segment. We want to kind of have an understanding of how many potential impressions are even in that space. Then after that, we look towards frequency caps. So this is, I only want to reach a person a certain amount of times in a certain time period. Then we have win rates, because these are auctions, so fundamentally you win or lose them. And we need to know how often, given your pricing strategy, that you will win, because if you're never going to win, then you're never going to spend any money. And then finally, we kind of end up by pulling these all together, we end up with your expected impressions, expected spend, and a whole bunch of other metrics. Okay, so we're going to start at the very top of the funnel. Potential available impressions. So basically, this is one of the most complex parts of our kind of space, because it's the sheer amount of permutations. So you can decide your geo, you can decide what websites you're going to buy on. When I say geo, geography, and each of these we call them rails or dimensions. There's about 100 of them, and the cardinality of the different things you can do with these it ranges from just a few up to millions. And basically, you can imagine that if each of these can be permuted, like a dice roll, and you have some dice that are insanely big, you can imagine all the different dice rolls that can come up. And basically, the long and short of it is we end up with more permutations than there are atoms in the universe by a huge amount. So basically, we can't pre-cache everything because it's physically impossible to know, to be able to load all of these. We would need a database as big as a planet. And so we rely on data sketches. And basically what this allows us to do is to get effectively like an arbitrary set representation. And we'll go into that a bit more in the next slide. And we can do unions and intersections of some predefined pre-cached space. And when we combine them together, we're able to get out approximations for the count of impressions. So to make this a little more clear, so like I said, we can't pre-cache everything, but we can pre-cache certain things. So we can say stuff like, we can create this arbitrary I'm going to call it a set representation for country being in the UK, or device being on iPhone. And we can do that for a countable set of these. There are some places where it's a bit hard to do, but for the most part, instead of having to now store country UK and device and blah, 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 and all the different permutations, now we're just taking this individual segment, and so we can store some of these segments. So take this through a really concrete example, we'll go for, we want to know the potential impressions we have that are in London or Sussex on iPhones who like cats or dogs. And I use or properly here because this is all kind of set notation, really, and you'll see it as we go through. So we go grab this arbitrary sketch for London. Then we go grab the kind of sketch representation for Sussex. Then we go grab one for iPhone users. for those who like dogs, those who like cats. The eagle-eyed will see that there clearly are some people who like cats and dogs. And then we're basically just applying unions and intersections to these. So we union, so it's London or Sussex, it's cats or dogs, it's iPhone users, and then we intersect all of those. And what we get out is there are, I don't know how many there would be for this one, but let's say there's 1 million potential impressions. It's just a number. And we also get some kind of confidence intervals around that space as well. So we have our space of potential impressions given your targeting settings. Now, given that we want to avoid overexposure, because I don't know, if you must have had it at times where you've had an ad that keeps popping up and eventually it kind of pisses you off and you click on the little button to tell it to go away. We want to try and avoid that. And one of the ways to avoid this is through frequency caps. There are softer approaches where you change your pricing structure to kind of downweight. But like a very common one that advertisers like is frequency caps. It's a hard limit, and it just says, given some time period, a week, I only want to show this ad to them 10 times, so I don't oversaturate them. And ultimately, we need to take these into account because what it's going to do, right, is reduce our space. And the more restrictive these F-caps are, the more restricted your space gets. And how we do this is via what we call frequency distributions. So a frequency distribution is basically, and I will admit I should have made these a lot bigger, but on the bottom here, we have the number of ads a user saw, and then on here, we have the kind of percentage of users. And basically what this is saying is kind of if we're looking at the tail end down here, that's users who could have seen an ad loads of times, and at the end, the other side, they only saw them very few times, and generally they group around the middle, right? And what we can do, similarly to what we had on the sketch side, is we can pre-cache certain bits of segment and know the distributions, and then we can try and combine them. And we have a cool model here. I won't go too deep into how this works, but basically what it tries to do is take in these distributions, sets of distributions, and tries to work out how they all kind of intersect and union together, and ultimately spit out its own predicted distribution. And then given that we have that distribution, we now know, oh, well, there were some users who would have seen the ad 100 times, but they only want to show the ad 3 times to them. We can basically just cap it down and say, well, only let them see it 3 times. And through that process, basically you get a number between 0 and 1 that says, if it's near 0, I'm going to reduce my space a lot, so frequency caps are very impactful. Or we get a number near 1 where it's like, to be honest, most people aren't going to see the ad a lot anyway, so don't worry about it too much. Cool. I think that covers frequency distributions. So we can move on to win rates. So win rates, and there isn't too much on this, but in terms of how we model this problem, so we know that now that all the auctions you see for ads take place in an auction that takes place over 100 milliseconds, and we need to know if we're going to win or not. And it's fairly obvious, I think, that the fundamental driving force behind this is the price you're willing to pay. So given some segment of inventory, so there's like premium inventory, which has a kind of higher price you'll typically pay for it. It would be like CTV. Showing ads on Disney is not the same as showing ads on some random smaller website, perhaps. And so, but each kind of pocket of inventory, you can create what we call win rate curves. And basically what they say is, what's my probability of winning given that if I were to bid a certain price? And I guess what you can think of, right, is that if you were to be crazy and try and bid, $1 million for every impression, you are going to win them all. It's incredibly wasteful, and it would be a very bad idea, but people will let you do it. Now, we do have some products that help you stop doing that, but again, that's last year's talk. But given that we know the inventory you're buying on, effectively what we can do is create a whole section of a whole set of win rate curves, and say, given in that particular inventory, we know you're going to bid about this. Your win rate for that inventory is this. Your win rate will be this, will be this. Take an average across all of them, and you end up with a win rate. Again, number between 0 and 1. Broadly speaking, if you are bidding low, it's going to be near 0. If we're bidding high, it's going to be near 1. Okay, and then we slap it all together. Something like that. Now, this is, of course, a huge oversimplification, and some of these kind of components play into each other. But I don't think we've got the time to go through that. Again, if someone wants to know a bit more about this, we can talk through it. Maybe ask a question, or we can talk through it at the stall. But basically what we're doing is we start broad, and then we add scaling factors, and we end up with some number that we think you're going to be able to place this many ads given you're willing to spend this much money. And then on top of that, we can then give the other metrics, so it's like reach. So given we know the frequency distribution, we can try and imply how many people will see the ad more than once and use that to reduce your kind of impression space to your reach space, if you will. Yeah. I think that's pretty much all on this slide. There is one thing I want to touch on as well, which is something I glossed over earlier, which was decision power. Now, this metric decision power, conceptually, is given the space you have, there's the opportunity to spend, I don't know, £1 million or $1 million. If you have a budget of $1 million, there's a chance that we got it slightly wrong, and also there's a chance that basically you might not be able to spend your budget. And there's a sweet spot, and decision power kind of tries to find this sweet spot for you, which is you want your target, the space that you're targeting to be, let's say, specific enough that you are targeting the right users. You know, if you sell a product that can only be shipped to the UK, you don't really want to be advertising it in Argentina because it probably won't be that useful. So you want it to be specific in that way, but you want it to be broad enough that ultimately we have the space to be a bit more choosy about the impressions that we're actually going to buy. Because if we're able to get to them cheaper, for potentially they're mispriced, let's say, we can capitalize on that. But if you constrain the space too much, basically the real-time bidding team isn't able to do that. And that's kind of where forecasting helps the real-time bidding team. We make sure that the campaigns are set up right so they can do their job the best. Now, we're going to dig into the one metric I didn't say anything about, which was relevance. So it's a relatively new metric to us, so I kind of thought it deserved its own slide. And some of the kind of DS work behind it's really cool, I think. I'm not going to be able to go super deep into it, but I think I can hopefully have people walk away with kind of conceptually how this works and why we have it. So let's start off with what is relevance? So relevance is a forecasting metric that, thank you, that tells you the degree of similarity between your set of inventory and your seed, which I'm sure people will now go, well, what the hell's a seed? Don't worry, we've got a slide for that. So a seed fundamentally is just a set of users. So what this set of users should be is your most valuable audience. And typically, this is derived from first-party data. So this is probably going to be like the people who've previously purchased your product, for example. But if you don't have that, you could use third-party data or some kind of proxy. But ultimately, you want to represent a set of users and say, look, these are the people, these are the type of people we think are going to interact with our products or interact with our ads, and then ultimately, ideally, with your product. So how do we calculate relevance? So basically, we can look at the historic actions taken by a user, and then we can, in an embedding space, we can create an embedding for this to kind of encapsulate those behaviors. And so conceptually, you can think of this embedding as basically like a taste vector for those kind of familiar with something like collaborative filtering. And an example would be, maybe I browse the New York Times in the day, and then I watch Disney shows in the evening, and then perhaps there's a similar user around in the space that hasn't perhaps taken an action, or maybe has taken, let's say they've taken an action like bought something on Tesco groceries online. I can declare that one as well because there's some articles online saying dunnhumby are a partner of ours. And maybe I haven't interacted with it. Maybe I'd be a good user to target. And that's kind of conceptually how to think of this. It's kind of like collaborative filtering, but not quite. So how do we calculate relevance? So given we have some seed, and we know for some given set of inventory, so some potential impressions, we know the users within that. We also know the users within your seed. Basically, we can use these embeddings to get a sense for how close your inventory of choice is to your seed. And so like the main thing to kind of take home from this is if you have a lot of users in some space that are doing similar actions to those who have maybe previously purchased your product, perhaps you're not targeting them, that's where this metric comes in. It gives you a sense of this is maybe the audience you should be targeting, and maybe you're missing out here. And this is exactly how we use it. So within our UI, this is a really great kind of tangible example of how you can actually put a data science metric in front of our customers or our clients and actually have them use it, and ideally use it to kind of make better value for them. And so in this particular example, we say, look, you're not targeting travel enthusiasts, but from our data, we know that we have data that would suggest that people who are travel enthusiasts would interact well with your product. I don't know, maybe you're selling something that appeals to them. But if you're not targeting that segment, then you're never going to buy it. And the idea here is that we give you an opportunity to expand your universe that you're targeting into areas that are incredibly relevant, and then the real-time bidding team comes along and has a chance to buy those. So yeah, it's basically trying to shift customer behavior ultimately to drive value for them. Finally, we're going to have a little look at the client view or the UI view. So this is the Trade Desk UI, and some of this is from training we have, so I don't have to be too worried about the numbers. They're not real, so don't go away thinking they're all real. We're going to have a little look through and kind of get a real tangible understanding of how each of these products looks. So, how do our clients use our forecasts? This is Trade Desk UI. This is Kokai. We've got a new release here. And this is exactly what it looks like. Now, the main thing I want everyone to look at is this red box in the corner. It's what we call the shopping cart. And basically, what happens is a user makes changes, and we immediately forecast those changes so they can get very quick feedback on what their changes to their campaign are going to do. So for example, they go ahead and they take one of our recommendations. It will reflect up here and it will say, look, if you were to put this change into production, this is what your space might look like. The idea here is kind of human ML combined, right? Where you give a suggestion, but at the end of the day, the end user is still taking that choice. Because we can't guarantee, I think all of our suggestions are fantastic, but maybe the customer knows something we don't, and that's okay. So we kind of work in tandem there and say, look, here's your fleet of options. We think you should do this. They give it a go, and obviously we think this, we know that this does actually give them great returns, so we like this. And then finally, we have what we call the F tile, which is the forecasting tile. So in the previous view, that was you had a running campaign, and you wanted to understand as it was running, what if you could make some changes to make things better. This view is more about kind of speculative areas. So we have a brand new area. We want to see what would happen if I did anything. And basically on the left, you can select your targeting settings, your FCAPs. You can select everything you need. And then we will produce a curve for you that with every metric you care about and say, look, with the budget you have, this is a good place to target. This is your relevance. This is how much you can spend. These are your impressions. And the idea here is then they can go, oh, well, actually, we were more thinking about this. And then they can go back and forth, play around with their forecasts until they're getting a space that they think is worth targeting. Yeah. And that, I think, is pretty much it. So thank you very much, everyone. Hopefully you'll have a little bit of a better understanding of the Trade Desk, and in particular, like I say, exactly how these solutions actually have impact. And I think that's probably one of the most important things, right? Because we can build stuff, but we need people to use it.
Great. Thanks, Ed. Any questions?
Thanks a lot for the presentation. Very, very interesting. Any pointers on how you interpret because I think when you talk about relevance, I think there's some kind of recommendation engine going on there.
To an extent,
so any any sort of ways in which you provide explainability or,
That's a good question.
Major issue with, rec systems.
Yeah, so that's a really good question. So just to repeat that, make sure that this gets picked up. So do we provide any kind of explainability for particularly our relevance metric? So for one, we do have a tooltip that tells you specifically what you should expect that metric to mean, because although it was just a number on there, that number does actually mean something. And specifically what it means is it's a multiplying factor. And what it means is compared to another set of inventory, how much more likely or how much more similar is this inventory to your seed? And so when it says 80, it says it in the 80x. And the explainability behind this is it's 80 times more likely to have the kind of users that you say you want there. And so it's explainable in that respect, but I think we're always looking to make it as clear and tangible as possible. And it's an excellent question because we try and make sure as much as we can that these metrics actually make sense. And so there's a longer guide on our website that explains exactly how you should interpret relevance. Cool. Another one over there.
Hi, Ed, and thank you for your really humorous and interesting speech about that. And actually, I have two questions. Firstly, I know apparently you have the big data and you also require it to be really low latency. So I'm curious, what is the most challenging problem and you view from the engineering side? And I'm asking because I'm an engineer and I need to do a lot of things about Spark and optimization. So I'm really curious about this. And then my second one is more about it seems that you have the 3 different teams from before campaign to after campaign. So I'm curious if there would be a feedback loop, and for example, the after campaign and kind of the metrics could also help with your forecasting, and how does that work, and what are the impact from that? Thank you.
Sure. Oh, those are awesome questions. So I'll just quickly repeat them, make sure I get those right. So the first one is basically what's the hardest kind of engineering problem, particularly with the scale, and the second question. So I've already blanked it. I'll answer the first one, then I'll remind myself of the second. So the first question, what's the most difficult problem? So I will quote Jeff Green, who is the founder of the Trade Desk, and he said that forecasting is the hardest problem in ad tech. So big shout out for my job. And I think to be fair, we have a whole bunch of scary problems, and you've got I would recommend having a chat to some of the guys on the stall after this about some of the real-time bidding space, because the latency requirements there are just batshit. They're just mad. But I think for us it's it's forecasting, and it's just the fact that we have so many rows, and the annoying part is knowing when we can aggregate and when we can't, because anytime we aggregate we can lose accuracy, and we need to know that granular detail. And sometimes we lose that granular detail. So we have to kind of take a big trade-off there between not only it's accuracy, speed, and then how far we go, what do we support? We don't support quite everything in forecasting, but we try our absolute best to. So from an engineering standpoint, I would say some of our ETL pipelines have put up our bill a fair bit. I think we had an intern who managed to run up a bill that I'm not going to say, but definitely trying to do all of that in tangible time is absolutely nuts. And if you can remind me again of the second question.
I'm curious, if there is one feedback loop, and from the after campaign to the before campaign.
Yeah, so again, excellent question. So just to clarify here, so basically what we have is how are we taking data that comes out the back of our campaign and feeding it back into the next campaign. So I think there's kind of 2 ways this happens. There's kind of explicit and implicit. So we've got explicit, which is where ultimately our clients, when they see their campaign, hopefully doing as well as they hoped, but sometimes during the campaign and sometimes after, they retrospectively look and they can go back and we have the analytics where they can say, oh, these are the kind of users it was working for. Maybe I need to redirect my campaign. Obviously, we try and help that through relevance. There's also like an implicit way, and this is stuff like all of our ML models, right, are based off historical data. And so we have a product called Value Algo, and what this does is tries to work out how valuable each bid is for that particular ad group or campaign, and given the user or impression space that they're targeting that particular impression. And basically, the implicit loop there, right, is the fact that if that user interacts and buys the product, that then feeds back into our model, and we're going to target more people like that. So there is absolutely a feedback loop, and I think definitely on the slide I had before, during, and after, could have done like a big arrow, right, that points from one to the other. But yes, there's, I'd say implicit and explicit. So the ones where we make a suggestion, and the ones where our ML works in the background and just does it for you no matter what.
Thanks, Ed. I'm afraid we've run out of time for questions, but I'm sure Ed would be happy to catch you at coffee or at the bar later. Thanks very much.
Cheers, guys.